All right, let's talk next about the hypergeometric distribution. And that is a distribution which is typically being used for questions related to drawings without replacements. And so a typical question would be, let's say you have a bowl, and in that bowl you have, for example, 1, 2, 3, 4, 5 red balls, 3 blue, and 2 green. So if we ask, for example, the question, in a sample of 2, so I can draw 2 balls, what's the probability that I get 2 green? So let's write that as the probability of 2 green in 2 drawings. Well, we can calculate that easily, so we know that getting the first green ball in the first drawing has a probability of 2/10. But then once we take one out, because it's without replacement, there are only 9 balls left and only 1 more green, so that is times 1/n. So we get 2/90. And that is, if you calculate it, it is 0.0222. So it's like 2.2%. It's a very slim chance. But the hypergeometric distribution can also be used, for example, when we have the question, what's the probability that we get the 2 green balls in a sample of, I don't know, 4 drawings or 5 drawings. So, yeah, let's say in 5 drawings. So that would be also covered by the hypergeometric constitution. But now it already becomes a little bit more complicated, because so now we have to ask, what's the probability of getting the 2 green in 5 drawings? Well, it can be, the 2 green balls can be grabbed in the first 2 drawings, but then that's fine. Then, but it can also be that 3 times we get something else, not a green ball, and it's only the last 2. We probably could figure it out if you had plenty of time and wanted to figure it out manually. But once it gets this complicated, we just would have to use the formula that we have in Excel, which is Hypergeom for the hypergeometric distribution. So in this case, Excel wanted to know, so if you take a look at this one, sample S. So in Excel language, sample S is the number of successes. So in our case, we want the 2 green balls. So 2, and you can put green balls. That's what we want. Then Excel wants to know, what's the number sample? Well, that would be the 5 drawings. So number sample, maybe it's a weird name, but number sample is essentially the sample size. So number sample this is essentially the number of drawings. So let's say 5. Then Excel wants to know next the population successes. It wants to know how many successes, which are our green balls, are in the population. So in this case, it would be population S. That is 2, so there are like 2 green balls in the entire population, and we both want to draw them in our sample of 5. And the last question is, what is the total number of balls in the sample. Okay, and then it becomes just, that's n, that is the number population. That's right. So in Excel, that's number population. Number pop. Okay, so I'm not so sure whether those are the most intuitive labels, but that is what it means. So here we have 10. And then lastly, it wants to know, is it cumulative or not? Okay, so let's actually see how that works in Excel. And let's pull up an Excel sheet here. Let's first replicate the first one, the 0.022. So we would call the function hypergeometric equals hype, and then it already comes here. Okay, sample successes. I want the 2 green balls. How big is the sample? Well, in the first it was also 2. Then how many successes are in the population? Well, 2, because there are 2 green balls in the bowl. And how many do we have in total? Well, that's 10. And from that, Excel can calculate the probability. And unless we did a mistake, we should see now 0.0222. And I forgot, of course, the cumulative. I always forget this one. So we don't want it cumulative, we want exactly 2. And that is a 0.02222. Okay, let's do the next one. 5 at 2 green in 5 drawings. So that is equal to hypergeometric. Dist. Okay, so now we have 2 in 5 drawings. 2 are in the population. There are a total of 10 balls. Again, I don't want it cumulatively. So that is also, it looks similar, but that is 0.222. Okay, so do we have another example here? What's the probability that you get the 2? Oh, okay, that's a good one too. So 2 red balls when you take a sample of 4. Okay, so let's maybe see if I can make that a little bit smaller and enter it here. Okay, maybe that. Okay, so now we have enough space. So, okay, so now this question here. 2 red balls. So we would say hype geom dist. We have to start with the equal sign. Okay. So, okay, so we want 2 red balls. Okay, in a sample of 4. How many red balls are there in the entire bowl? Well, we have 1, 2, 3, 4, 5, and a total of 10 balls. Okay, so that is equal to, let's forget the cumulative yes or no, 0. So it's the 0.476, which you see here at the bottom. So that is the hypergeometric distribution, a pretty powerful tool. I just don't know how often in life you actually encounter a problem like this. But I guess it is important for, games like poker or, similar games where drawing without replacement plays a role. Anyhow, so I hope that is clear, and the next video we still talk about the negative binomial distribution.